Hey Ashley, so I wrote all this down and I'm gonna explain it really quick. I just want to have it all down so I could point out to you before we got into everything. So right here, right, this is our base compound interest formula, and that's what we need to solve most problems. But the ones we're doing have additional payments, and that's where this second equation comes into hand, and this is all one equation. As you can see, the first part of it is just simply that beginning part of our problem. So if you want, do the first part, and then you can move on to the second part of the equation, which is what we're going to do here. But for obviously, you can see here, it's just the same exact equation as regular compound, but it has this new equation, and this new equation has two new variables. That's where you have this PMT here, PMT, which is our additional payments. So if they're putting in $5,000 every month into the account, that's where that would be $5,000. This P here is because what would you call it? It would be the number of payments in the compounding year. So just say number of payments in the year, in the period, I should say. So we'll explain what that means. Kind of like in our first example, that lady with the $325,000 she wants to have, the interest is being compounded quarterly, but she's putting in the money only yearly. So that money has to be accounted for in this variable here. And so we'll get into that. So with that first question, right, she wants to have a total of $325,000, and by doing that, she wants to put in $80,000 as a principal, the rate of 5.5% or decimal 0.055. The term over 20 years, and she's doing it quarterly, so our N is 4, and our PMT, she's adding this much money per year, which leaves only that little p variable, and little p variable can be found as what they're putting the money in as over the period divided by N. So that would be, in this example, she's putting in the money yearly, so that means she's putting it in once yearly, even though it's being compounded quarterly, so 4. And that's what you do, 1 over 4, because she's putting it in once a year when there is 4 periods during the compounding a year. We can write that as a decimal of 0.25. And now it just takes doing all of this together. So we're going to write out the equation. Let me move my keyboard here so I have more room. We're going to write out the equation. We're going to write the whole equation out with all the variables over here, and then we're going to break it down and do the first part regular, and then we'll do the second part too. So the first part, let's just write it out. Let's do it right. Let's do it right here in the light. A equals our principal of 80,000. Don't forget the bracket. 80,000 times our 1 plus our rate of 0.055 over quarterly, N, 4, to our NT, and as we discussed, NT is just 20 times 4, so 80. Bracket there. Ooh, I'm going to run out of space. Let me see if I can. Ooh. I have my phone balancing on a book. I don't think this is going to work. Okay. In fact, that's actually a good idea. This is our first part of the equation, right? And we're adding in that second part here. We're adding in the second part, so we'll write that below it so we can kind of just break it down even more, because we're adding in now our PMT, right? Our PMT, which would be 3,500, times our little p, which would be 0.25, times 3 parentheses 1 plus our rate of 0.055 over our N, which would be 4 parentheses NT, which we agreed was 80, minus 1 divided by our R over N, which R over N would be 0.055. Make sure I did this right. Yep, R over N, and our N would be 4. And N2 parentheses. So now that we kind of see both of them broken down here, we can just do the first one. And we do that just by putting in a calculator, right? Just like we did over the video. Just put it right in a calculator. It ain't going to do any harm. I do not expect anyone to do this by hand that hasn't done much more before. So we'll do this plus fraction 0.055 divided by 4. Oops. To the 80th power. And for that first part, we get 238,538 and 90. Ooh, yeah. Well, I'm gonna try to readjust my book here. There has to be a way. Oh, I know a way. Just put all of that. There we go. Will it stay though? Yeah. Well, cool. $238,538.98. So that's for that first one. Now we gotta do the second one, and we can again do that by putting all this in a calculator, or we can kind of try to break it down into smaller bits. I'm just gonna put it all in a calculator. Actually, let's break this down into smaller bits first, and then I'll just show you that it's also doable just putting the whole thing in a calculator if you're very, very careful. Because of all these brackets and parentheses here, you've got to be careful. So let's break it down. Let's do this beginning part. 35, well, let's just do PEMDAS, right? Parentheses. Do what's in the parentheses first, and the most inner parentheses is this part here. This 1 plus 0.055 over 4. So, in your calculator we go. And we get, this turns into 2.98173. And then minus 1. Divided by 0.055 over 4. Parentheses, and 3,500 down times 0.25. All right, so now we kind of made it a little simpler, but it's not too right. So let's keep going. This minus 1, well, that's easy, right? That's just 2.98173 minus 1. You can probably guess what that's going to be. And that already gets rid of one of our parentheses. Now we got 1.98173. No, not entirely, it doesn't. Divided by 0.5. I always forget 0.55. That's my fault. 0.055 over 4. Why did I put a 4 here? I'm sorry about that. That's supposed to be parentheses. I don't know what my brain was doing. Oh, I know what I was doing. Good Lord, I'm sorry. That is supposed to be there. That's for this part. I'm sorry. So yes, over 4. So now we can do this part, right? We got to divide this by whatever that is. So let's figure what this out is. Figure what this is out. I can't speak. We're going to figure out what this fraction is. So bring those parentheses down again. 1.98173 divided by, and what is 0.055 divided by 4? That'd be 0.01375. And now we just got to divide that number. So we take our number here, right, and divide by that. So 98173 divided by 0.01375. Enter. Oops, I put an extra decimal in there. My calculator's gonna freak out. Yeah, I gotta rewrite that. 1.98173 divided by 0.01375. Enter. And we get about 144.125, and that's what we get in that parentheses. And that breaks it down because now we go back over here and we bring this down, and we get 3,500 times 0.25 times that. So now we gotta do more parentheses, right? So we gotta do 0.25 times 144. So 0.25 times 144.12581. And we get 36, and this becomes now 3,500 times, and we get an answer of 36.031. 314,525. That's what we get. So now we gotta multiply that number, right? So 3,500 times 36.0314525, and we get an answer of 126,000. And once all this is over, this is going to equal. My pen is running out of ink. Hold on. There we go. And once we do that final calculation, it's going to equal 126,110.08. That's going to be 0.08. It's about that. We don't need the rest of those because they're going to trail off anyway. So this is what we get for the second part of the equation. And now that we have that second part of the equation, we have to add it to this part of the equation. But if you look at it, you should add these together. Oh, I knew that was going to happen at some point. Oh, sorry about that. It's kind of the unfortunate parts of working from home in such circumstances, not having recorder software, all that. So once you don't really need to add these to figure out what's going to happen, but we should add them, and we're going to see right away. Like if you just kind of look, 238,000, even adding another 100,000 is going to put it over that marker. But if we add them together, these are going to equal. Let me put that in a calculator here. I'm not going to use the cents because it's not really worth it right now. 538 plus 126,110. We get around. Yeah, you get about. Oops, sorry. That's supposed to be a squiggly line. This is the how you write approximately. It's kind of like it's about there. So it equals approximately 364,648, and she wants that in dollars. And so if we look, yes, she will have that much amount of money. So this one is yes, she will. This is, like I said, very complicated problem because of the second part of the equation you have to do. So go over it slow. If you need more help, please let me know. Like I said, we're not technically open tomorrow or the weekend, but seeing as how I know you need to get through to get the graduation and everything, I am more than happy to be here and helping you. So just contact me if you need help again. We can go over more of these. The other ones that you put on here, not you didn't put them up here. The other problems are exactly the same. Yeah, these ones are exactly the same. I will say on 3.020, the last problem, you don't need the first part of the equation. You don't need this first part. That one has this part of the equation. You just need this part of the equation. In the last one, you just need this part of the equation. The other ones, you will need to do all of it. I don't know if they give you a different equation here. This is just the one I was taught in college. So if they give you a simpler one, use it. If it's more easy or it's easier for you to do than this one. And if you need more help walking through, we can again schedule their Google Meet. If it becomes worse, actually we couldn't be able to do that. I was gonna say we could go to campus, but they want to be open. I'll be able to work with you as much as you need on this stuff. So let me know if it helps. If you get through this, start working on a practice test and let me know how that goes, and we can get you through this. So good luck, Ms. Ashley, and have a good day.